Hello everyone, I welcome you to my class, and this will be the last video on the theory part of 3 dimension, and this will be a short video, and we'll be discussing some important concept. Okay, the first concept that we are going to discuss is that equation of a plane passes through the intersection of two planes. See here we have taken two planes, pi1 and pi2. So what you need to do is we need to find the equation of this plane, that is pi3. So for that, what I'm going to do is we'll just take the equation of this plane, pi1 and pi2. So let's start. Let the equation of pi1 be we have taken the equation of pi1 in normal form, that is r dot n1 cap equal to d1 pi1, and the equation of pi to b, so r dot d2. Say this is equation 1, this is equation 2. So now we'll take a point in the line of intersection of these two planes. So this is a line of intersection. So we'll take a point and any point on this particular line, and we'll take the position vector of that point. Okay. Let t be the position vector of a point in the line of intersection of pi1 and pi2. Okay, we have taken, so what we have taken the equation of this plane pi1, okay, r dot n1 cap equal to d1, and the equation of plane pi2 we have taken is, both the equation we have taken in normal form, and we have taken any point on the line of intersection. This is the line of intersections. So we are assuming that let t be, this t be the position vector of a point in the line of intersection of pi1 and pi2. So now, since this point, right, this is a point, okay, in the line of intersection of both the planes, therefore this vector, that is position vector, will satisfy both the equations 1 and 2. So therefore we can write, so we can just replace r by t, that is t dot n1 cap equal to d1 and t dot equal to d2. Now these two equations can be written in the form of, we'll take any real number lambda, and we'll just multiply this equation 2 and we'll add it d1. So this can be written as t dot n1 plus lambda n2 equal to, what we have done, I'll explain it a little bit first, right? So we have taken one lambda is any real numbers. So what we'll do is we'll just multiply this equation by lambda, we'll add it equation 1. So therefore, and t dot n1 plus lambda n2, and right hand side will be d1 plus lambda d2. So equations with the help of this one, and we can write in the form of this. Now, since t is any arbitrary point, let's go back to the previous page. Since t is any arbitrary point on the line of intersections, therefore any point on the line will satisfy these equations. So these equations will be satisfied by any point on the line of intersections. Now, let us consider the equation of, we'll consider the equation of planes. Let us consider the equation of planes as r dot d1 and r dot n2 d2. Then from these equations, okay, multiplying the second equations by lambda, we can write the equation of the plane which will represent, okay, right, which will represent the equations of pi 3 can be written in the form of, okay, we can write in the form of, let us consider the equation of the plane as, if we consider the equations of the plane as, first plane is this and second plane is this, then the equation of pi 3, that is equation of the plane passes through the intersection of the two planes, then equation of pi 3 can be written as, okay, exactly similar form, r dot factor n1 plus, okay, here the factor n1 and factor n2, lambda n2, okay. So the method is same, we are just multiplying the second equation by lambda and you are adding with the first one, so it is d1 plus lambda d2. So this is a very important, okay, equation of a plane and in a vector form, okay, which is passes through, right, okay, which is passes through the intersection of these two planes. Okay, now we'll derive, just let's move to the next plane, next equation, right, next page. So just now from this equation we'll derive the Cartesian form. So for that, okay, we'll just need this page. Okay. So this is very important, please note down and okay, Cartesian form. We'll start the Cartesian form now. Cartesian form. Okay, for this we need to remember that the factor equation of the plane. So this is r dot n1 plus lambda n2 equal to d1 plus lambda d2. Right? Okay. This is d2. Fine. Okay. Now what I'm going to do is, so r is a position vector of any point on the plane. So therefore we can take r as x I cap, y j cap and z k cap. And n1 you can take as, okay, this is n1, right? This n1 we can take as, that is, okay, a1 I cap, b1 j cap and c1 k cap. Then what is a1 b1 c1? a1 b1 c1 is the direction ratio of n1. Okay, and similarly n2 can be taken as a2 I cap, b2 j cap and fine, c2 k cap. What is a2 b2 c2? Similarly a2 b2 c2, a2 b2 c2 are the direction ratio of this vector n2. Fine, yes. So we got r, n1, n2 which are being used in this equations, that is r is a vector, n1 is a vector, n2. So you have written all the values, that is r. So this is the position vector of an arbitrary point and generally r we write in the form of xi, yj, j, k. Now first we'll add this n1 plus lambda n2. Now n1 plus lambda n2, okay, n1 plus lambda n2. n1 plus lambda n2, if you add this, so if you take I common, right, this will be a1 plus lambda a2. Fine, if you add this, then you multiply n2 by lambda and if you add. So if you take a1 I cap and lambda a2 I cap, so if you take I cap common, so I cap a1 plus lambda a2, then similarly you can just write j cap b1 plus lambda b2 and similarly k cap, you can write k cap, that is c1 plus lambda c3. So you got this value, that is n1 plus lambda n2. Now if you put this one as say, Okay, right? So from the equations, okay, so what I'm going to do is R dot this. What is R? R is these vectors. So if you use a dot product between R and this n1 vector plus lambda n2 vectors, so you have to use a dot product, that is I dot I. This term will be 1, I dot I is 1, so you will get this term, that is a1 plus lambda a2. So from this equation, that is star implies, so if you use a dot product between these two vectors, okay, so I dot I is 1, so the first term will be a1 plus lambda a2 x. What is the next term? Next term, you multiply this second term with the second term, that you will get b1 plus lambda b2 y. So, and third term will be c1 plus lambda c3 z is, okay, right hand side is not 0, is equal to, find d1 plus lambda d2. Okay, so we first got the value of n1 vector n1 plus lambda n2, and we know the value of r, and we'll be using dot product between this vector, okay, between this vector, vector r, and between this vector, right? Yes, these vectors. If you use the dot product, so you'll get the first term x into a1 plus lambda a2, right? a1 plus lambda a2 and x. You'll get the first term, similarly you get the second and the third term, and the right hand will remain as it is, d1 plus lambda d2. Okay, now, so what I'm going to do is, it's almost done, we'll just simplify a little bit, okay? We'll just simplify these particular steps. So you can just use this space. Yes, so what I'm going to do is, first, okay, we'll just write the terms, right? a1x, so this implies you can just write a1x, then next we will write b1y, then next we will write c1z, right? c1z, all the terms we will write which is free from lambda. So just a1x, d1y, c1z, and the right hand side which is the term free from lambda, that is d1. So if you transpose, it's minus d1. So you got this, and take all remaining terms, you know the lambda is there, so take lambda common, so it will be a2x plus b2y plus c2z minus d2 is equal to 0. This is a very important and simple equation of plane in Cartesian form. Very easy to remember, okay, very easy to remember. This is the equation of the first plane, right? This is the equation of the first plane, that is pi1. This is the equation of the second plane, that is lambda pi2 equal to 0. This is the equation of the first plane. In case if you just write, okay, in a shortcut method, you can just remember this. In fact, it's a pi1 is the name of the plane. So if you remember that, first equations of the plane in Cartesian form plus lambda, then equation of the plane in the Cartesian form is equal to 0. Okay, so this is the first theory of today's class, and next, okay, we'll just move to, right, yes, this is a very simple concept, that is coplanarity of two lines. On what conditions two lines will be coplanar? For that we need to know two lines, so we'll just take the equation of two lines in a very simple form. Okay, so let the two lines be, okay, let the two lines, so just write in this way, let the equation of two lines be, okay, we'll just take r equal to a1 plus lambda, okay, b1. This is, we know that this is the equation of a line, right? We have derived these equations in one of the videos. Let the equation of two lines be this, and a2 plus lambda b2. Yes, these are the two. Let the equation of two lines be this and this respectively. Fine. That means this is the equation of the first line. Say this is the equation of the second line. Now we have derived these equations as I said in the previous video. Let us again just revise this concept. So if you write an equation of a line in this form, that is in this particular, this is the most important and the first theory, an equation of line. So if you write r is equal to, we know that if you write an equation r is equal to a plus lambda b. So you know what is a. A is the position vector of a point through which the line passes. So A is the position vector of a point on the line, and what is B? B is a vector which is parallel to the line. So these are the points we have already discussed. So we're not going to discuss more on that. Okay. Now let's come to the theory. So what we have to find? Coplanarity of two lines. So let the equation of two lines be this and this respectively. Fine. These are the two lines. Now say if I just take a line. Say this is line 1. Okay. This is line 1. Now this is A1. A1 is the position vector of a point. Say if you take a point P, say point A. So the position vector of A is A1. Position vector of point A is A1, and this line is parallel to B. Right? This is B1. Fine. B1. Then similarly, if you take another line, say this is another line L2. So there is a point B. Right? What's the position vector of B? Position vector of B is A2. A2. And similarly, B2. This is B2. Okay. B2, which is parallel to line L2. Now, we need to coplanarity conditions. We need to find the conditions when these two lines will be coplanar. Okay. So we know that A1 means the position vector of a point on the line, and A2B is the position vector of a point on the line L2. So let us assume that that particular point be A on line L1, and this point B on line L2, and this is a fixed point on the line L2 with position vector A2. So first what I am going to do is, we just first find out AB. That is a vector joining 2 points. Okay. Let A be a point on line 1 with position vector A1, and B a point on line 2 with position vector A2. Okay. Now yeah, we'll just use this phrase. Now we'll find out AB. What is AB? Vector joining 2 points. This is A2 minus A1. So you got this. This is A2 minus A1. Now let's go back to the previous page. Now in case this L1 and L2, right, we got this this is AB, we got it, vector joining 2 points. Now in case L1 and L2 to be coplanar, that means these two, the line, if to be lying on a particular plane, say these two lines to be lie on this particular plane, then we know that we have to take help of B1 and B2. Okay, I'll just go back to the previous page. Fine. Okay. Now, if these two lines A1 and A2, okay, should lie on this particular plane, then just find a cross product B1 and this is okay. This is B1. Okay, B1 and B2. If we take the cross product of B1 and B2, so B1 and B2, B1 cross B2 will be a vector which will be perpendicular to this plane, right? Perpendicular to the plane, and if we join this, okay, if we join this, right, this is AB. Fine, this is AB. And if we take the cross product, that is B1 cross B2, B1 cross B2. Now what will be the direction of B1 cross B2? B1 cross B2 will be perpendicular to this plane, right? Perpendicular to this plane, and in case it is perpendicular, it has to be perpendicular on AB. And we know that if two vectors, okay, this vector is perpendicular to AB, then dot product between these two vectors will be 0. So we'll be using this simple concept, okay? you can just write in this this particular point, if the two lines to be coplanar, then or you can just simplify this particular line, the two lines will be coplanar if and only if AB, vector AB dot B1 cross B2 will be equal to 0. Okay, because B1 already I have explained that the B1 cross B2 direction will be perpendicular to the plane, right? And AB, since A is a point on line 1, B is a point on line 2, and if this two lines to be coplanar, then the dot product between AB and B1 cross B2 has to be equal to 0. So this will just replace AB. AB means A2 minus A1 dot B1 cross B2 is equal to 0. So which is a very important property, okay, right? Very important property, in fact very important conditions to decide whether the lines should be coplanar, two lines should be coplanar or not. That is A2 minus A1 dot B1 cross B2 is equal to 0. Now, so just derive the Cartesian form. Okay, we'll derive the Cartesian form. Okay, Cartesian form. So how to derive the Cartesian form? So to derive the Cartesian form, first we'll derive the vector form. A2 minus A1 dot B1 cross B2 equal to 0. Right? Yes. A2 minus A1 and B1 cross B2. So you can just take, let A1. What is A1? A1 is the position vector of a fixed point A. So if we take the coordinate of A is x1, y1, z1, so A1 can be taken as x1 I cap, y1 j cap, and z1 k cap. Similarly, A2, which is the position vector of the other fixed point, that is B, and we can take the coordinate of B as x2, y2, z2. So this can be written as x2 I cap, y2 j cap, and z2 k cap. Done. Okay. Now just we'll find out A2 minus A1. So if you find A2 minus A1, therefore A2 minus A1 can be written as, that is x2 minus x1 I cap, y2 minus y1 j cap, z2 minus z1 k cap. Okay, so this is A2 minus A1. You got this. Fine, A2 minus A1. Now B1 and B2. So let B1, right? You can take B1. If you know the direction ratio of B1, let us consider that A1, B1, C1 is the direction ratio of B1. So B1 can be written as that A1 I cap, B1 J cap, and C1 K cap. Remember this. This A1, B1, C1 are the direction ratio of vector B1. Similarly, B2. Okay, B2, you can just take A2 I cap, B2 J cap, and C2 K cap. Now what is A2, B2, C2? A2, B2, C2 are the direction ratio of this vector B2. Okay, yes. Now, since you got the value of A2 minus A1 and similarly B1 cross B2, so with the help of this particular expressions, you can write the Cartesian form. So we'll just write the Cartesian form. Okay, so you can just wrap this part. Okay, so we'll find the Cartesian form. Now, before writing the Cartesian form, let me explain you this particular form. Right. So you have seen that here, this is one vector dot B1 cross B2. Okay, so we know that this is a scalar triple product, so which also can be written as A2 minus A1 comma, B1, B2. We know that scalar triple product can be written in the form of this, or in case three vectors A, B, C are there, then you can write the scalar product in the form of this. These are all different form of writing scalar triple product. And if the three vectors are written in scalar triple product, so that can be written with the help of this, can be expressed with the help of the determinant, right? So therefore, if we mark this one as, say, one equation, say this is equation 1. Okay, so 1 implies, we'll just write in the form of determinant. Right? So while writing in the form of determinant, what you need to write is, you need to write all the x, y, z components. First, this is the first vector. So what are the x, y, z components? These are the x, y, z components. So first term will be, first row will be x2 minus x1, y2 minus y1, z2 minus z1. And what is the scalar component for the second vector, which is b1? This is a1, b1, c1. Similarly, that a2, b2, c2. So which is the Cartesian form, okay, Cartesian form of equations to verify whether the two lines will be coplanar or not. Okay, so we'll just move to our next concept. Let me check. Yeah, so we'll discuss this concept before that, right? What is the concept? Angle between two planes. Very simple concept. Angle between two planes. Right? What is okay? How do you find angle between planes? Right? So let's discuss about that. Say let us consider one plane pi 1, another plane is pi 2. So right, I'll just use this color, right? Pi 1 and pi 2. So let us consider, we are just using many symbols, don't get confused. Okay, that's what again I'll redraw this. Say theta is the angle, this is the angle. I'm just talking about this angle, right? This is the angle. Theta between this plane pi 1 and pi 2. Fine. Now, I'm drawing two perpendiculars. Okay, this is one normal, n1. Remember this? This is n1, right? This is a normal, n1. Right? N1 factor is a normal to pi 1. That means angle, this angle, since N1 is a normal to pi 1, this angle, I am talking about this angle is 90 degrees. Now in case this angle, if you take the angle between these two planes is theta, therefore naturally this angle has to be 90 minus theta. It has to be 90 minus theta, because why this angle? This angle is because N1 is perpendicular to this plane. Okay, which is blue in color, right? And if we take this angle is theta, then this angle has to be 90 minus theta. Similarly, okay, fine. Now, what is N2? Come this side, right? What is the vector N2? Vector N2 is perpendicular to this plane, that is pi 2. That means this vector N2 is perpendicular to pi 2. That means this angle is 90 degree. Now, in case this is 90 degree, and if this angle is okay 90 minus theta, so this angle has to be theta. This angle has to be theta. Is it okay? So I'll just repeat this. We're just using many color. You may get confused. Just again I'll show you. Fine. Again I'll show you that. I'll just repeat once. Fine. First what I'll do is I'll wrap this first one by one. Let me wrap this part. Let me explain it once more. Fine. Okay. Let me redraw this. I'll just redraw. Fine. Okay. One by one. Let me use another color. Let us consider this is theta. Fine. Okay. Again, I'll wrap this part also. Right? Yeah. You don't need to confuse so many colors. Right? Okay. Yes. But only you need to understand that this N1, yes. This is N1. Okay, so see carefully. This is a vector N1 which is perpendicular to pi 1. Now if this is theta and this has to be because this angle is 90 degree. If it is theta, this has to be 90 minus theta. I think it is clear now. Fine, 90 minus theta. Now again, think about the n2. What is n2 vector? N2 vector is perpendicular. This vector is perpendicular to pi 2. That means this angle. Come to this angle now. I'll just let me use this color now. This angle. This angle is pi. This angle is 90 degree. Now already you got this angle as 90 minus theta. So this angle plus this angle has to be 90 degree. Therefore this angle has to be theta. And this is quite interesting. Why? This theta is the angle between n1 and n2. But what did you assume initially? You did assume initially that let theta be the angle between the two planes pi 1 and pi 2. But after this particular steps, we have seen that actually this angle, which was considered as the angle between the two planes, is actually the angle between the two normals. So therefore, we are going to find angle between the two normals, right? So before that, what I'm going to do is we'll write the equation of pi 1 and pi 2. We should know the equation of pi 1 and pi 2. Fine? Okay. Now let the equation of pi 1, let the equation of pi 1 be, let the equation of pi 1 be r dot, right? R dot n1 equal to d1. Right? Let us consider the equation of pi 1 be r dot n1 r dot n1 equal to d1, and the equation of pi 2 be r dot n2 d2. So these are the equation we are just assuming. Fine. Okay. Right. Now welcome back. We'll continue with this concept, that is angle between two planes. So we have taken the equation of the two planes, like pi 1 as this r dot n1 vector equal to d1 and r dot n2 equal to d2, and n1 is a vector which is perpendicular to pi 1 and n2 is a vector which is perpendicular to pi 2. Fine. So also we have discussed that the angle between the two planes is same as angle between the two normals. Right. So therefore, we need to only find, if we need to find the angle between the two planes, it is sufficient to find the angle between the two normal, and n1 and n2. And we know that how to find angle between two vectors. So n1 and n2 are two vectors, so we can just find out the angle between the two vectors. So if theta is the angle between pi 1 and pi 2, then I think you can move to our next page. Then cos theta, right? We know that if cos theta is n1 dot n2 mod n1 mod n2. Okay, we know that how to find angle between our two vectors, right? n1 dot n2 divided by mod n1 n2. So this is the important formula to find angle between two planes. Now the Cartesian form. Cartesian form. Okay, and first we'll just, if we express n1 and n2 in terms of the direction cosine. So let n1, vector n1 is a1 I cap, b1 j cap. Okay, n1 a1 I cap, b1 j cap, and c1 k cap. What is a1 b1 c1? a1 b1 c1 are the direction ratio of this normal vector n1, and let us take n2 as a2 I cap, b2 j cap, and c2 k cap. And similarly, what is a2 b2 c2? A to B to C to are the direction ratio of N2. So we'll just put the value in this particular formula. Therefore, cos theta can be written in the form of, so if you use this dot product between these two factors, we get A1 A2 plus B1 B2 plus C1 C2, and the mode N1 factor gives us A1 square plus B1 square plus C1 square, done, and mode N2 is A2 square plus B2 square plus C2 square. Fine. So this formula is used to find angle between two planes, and in case that N1 and N2 are expressed in the form of this. Okay. Now let us discuss some important points. Say if two planes cut at right angles, right? If two planes cut at right angles, in that case, this theta will be 90 degrees, that means cos 90 will be 0. So in that case, you will get A1 A2 plus B1 B2 plus C1 C2 will be equal to 0. And in case the two planes are perpendicular, so perpendicular, so in that case, if perpendicular, that means their direction ratio, that is A1 A2, A1 by A2, B1 by B2 and C1 by C2 are in proportions. Okay, so we'll just mark this important point. So you can just write these as a note, right? Note 1. Note 1. If theta equal to 90 degree, then you can just write A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Fine. And what is note 2? If the two lines, if the two planes are parallel, then direction ratio of the normal factors will be in proportion. That is, then A1 by A2 equal to B1 by B2 will be equal to C1 by C2. Done. So these are very important conditions. We'll just move to the last concept. Yes, this is a distance of a point from a plane. Okay, what you need to do is, say this is the point P, right? This is the point P on space, and this is a plane. This is a plane pi 1. So we need to find a distance from P to this particular plane pi 1. Okay. So I'll just first discuss about the theory, and then I'll just note down the points. So let's A be the position vector of P, right? Let A be the position vector of P, and since this plane is given, because distance of a point is given and a plane is given. Say, let us consider the given plane is pi 1. So since the plane is given, so we know the equation of the plane. So let us first start with that only. So we'll just write, let the equation of plane, okay, let the equation of plane pi 1 be r dot, okay, r dot n cap equal to d. So this is assuming the equation of plane in normal form, right? Normal form, where what is d? D is the perpendicular distance from origin to the plane, right? That is ON. So we are assuming that this is d. Fine. So this is given. Now let the position vector of P be A. Let the position vector of point P be A. Now what I'm going to do is, we will consider a plane pi 2 through P, and which will be parallel to pi 1. So we'll just construct a plane. This is blue colored plane, and which passes through P and which is actually parallel to pi 1. So since this plane pi 2 is parallel to pi 1, and what is this is n cap. N cap is the unit normal vector to pi 1, and since these two planes are parallel. So naturally this n cap will be also perpendicular to this, the plane pi 2. And since we got a vector which is perpendicular to pi 2, apart from that, we know that this plane pi 2 is passes through this particular point P with position vector of A. So we'll use a very important concept on equation of plane. So if you remember that equation of a plane passes through a particular point and normal to a vector is given by r minus a dot n equal to 0. If you remember this, r minus a dot n equal to 0. So here in our case, for pi 2, to write the equation of pi 2, so we know that the fixed point direction, this is position vector is A. Apart from that, also this vector n also known to us now. Since these two are parallel, already I have explained. What is n cap? N cap is a normal vector to pi 1, so it will be also perpendicular to pi 2. Fine. So we'll just write the equation of pi 2. So let the position vector of point P be A. Since A, therefore you can directly write the equation of pi 2 is equation of pi 2. We'll just write the equation of pi 2. Okay, the equation of pi 2 is r minus a dot. Okay, what is the normal vector to pi 2? This is n cap equal to 0. N cap equal to 0. And if we simplify this, okay, if we simplify this, we can just write this implies r dot n cap equal to a dot n cap equal to a dot n cap. Fine? Right. Okay. This is a very important. Now, since equation of the plane is this, if we simplify, you will getting this r dot n cap equal to a dot n cap. So we have expressed this one, the equation of pi 2 in normal form. Now, what is this? The right hand side term will give us the perpendicular distance, that is the perpendicular distance of pi 2 from origin. That means a dot vector a dot n cap will be this one, your O n dash. If it is n dash, this O n dash will be given by vector a dot n cap. Now let's go back to equation 1, that is equation of pi 1. What is equation of pi 1? R dot n cap equal to d. What is d? D is the perpendicular distance of pi 1 from the first plane, that is this one. This is O n. So O n is nothing but d. O n is nothing but d. Now with the help of these steps, so this is the equation of pi 2. Concentrate on this part, r dot n cap equal to vector a dot n cap. So this one will be similar to d, right? Fine. So because it is, you are expressed in the equation in normal form, d. D means, since this is the equation of plane, so here, so you can just consider this is d1. That means the d1 means the perpendicular distance of pi 2 from origin, which is denoted by this. If we take this is n dash, this is n dash, so n dash will be given by a vector a dot n cap. Now you got the value of O n. What is O n? D. Now you got the value of O n dash. What is O n dash? This is O n dash. So based on that, you can just find out n dash n. What actually you need? You need the value of PQ. So PQ is same as n dash n. So n dash n can be written as O n. How to find out n dash n? N dash n can be written as O n minus O n dash. Okay. Now, okay. Now this PQ is same as n dash n. Now, okay, n dash n, you can just write n dash n. N dash n is same as O n minus O n dash. Fine. Now what is O n? O n is d. So this is the distance, so we can just use the mode d minus, okay, d minus O n dash. What is O n dash? Vector a dot n cap. Okay, vector a dot n cap. Fine. So this is the distance. Okay, this is the distance of plane pi 2 from a point P. So this is a perpendicular distance from a point P to a particular plane. So the theory is very simple. Okay. Yes, so these are the important theory, and next we'll discuss question answers from the last exercise and miscellaneous exercise in the next video. And thank you so much for watching my channel, and please do subscribe my channel. And this video along with the previous video, you have to because in this particular video we started with the concept that we started with this concept, that is we started with this concept, that is angle between two planes. But in the previous video where we discussed all these points, right, that is coplanarity of lines, and apart from we started from this particular concept in the previous video, that is the equation of a plane passes through the intersection of two planes. So this lecture in 6, after lecture 6 you go for the next lectures. So in case if you see all this the lectures, and your whole theory will be covered. Okay, and thank you so much. Keep watching my channel. Thank you. Bye bye.